not derivatives, the mean value theorem with derivatives. We took the secant line and found the average slope, or the average rate of change. And we found the value of x that would give us that slope. So what they're telling us there is that if I have a particular slope, there's some value, that slope will happen. Anyways, in that interval, that slope will happen. Okay, so hopefully I made that sense. Mean value theorem, we took a secant line, found the average rate of change with that secant line, and then pulled it down to be tangent to the curve. And we were able to find the value that gave us that instantaneous rate of change. Now, if we're doing integrals, we have the instantaneous rate of change, and they're just saying that within that integral, there's got to be that rate of change has to be an average in that integral. That's all it's saying. Okay, and then this is how we would find it. So on this one here, they're asking you to apply the definition. Now, since you do not know how to do derivatives or antiderivatives yet, we're going to use calculators on these completely through and through, but we can still set it up. So it's going to be 1 over b minus a times the integral of a to b of f of x dx. So this is going to give me 1, so let's do this to the side. B minus a is going to be 4 minus 0 or 4. So this is going to be 1 over 4 integral of 0 to 4 of 2 minus x squared dx. Now, if you threw this baby into the calculator, it'll give you negative 3.33333333. Anyways, it's repeating. You get something like this, ask it for a fraction, negative 10 over 3. You always want those exact values if you can give an exact value. So I don't know that they're going to say anything about using negative 3.333333. I don't know. But if you had to do something more to the problem, the fraction will be a much better use. Okay, so let's try this one again. Average value of f of x equals x squared minus 1 on the integral of 0 to radical 3. So still the same, 1 over b minus a, integral of a to b, f of x dx. And b minus a is going to be radical 3 minus 0, or radical 3. So we're going to have 1 over radical 3, integral of 0 to radical 3 of x squared minus 1 dx. You throw that into the calculator, you're going to get 2.35, and then it's going to give you e to the negative 14, which is scientific notation according to your calculator, of 2.35 times 10 to the negative 14. So you can claim this answer to be 0. There you go on that one. Okay. So one more on this one. We're going to play with this one a little bit, but we're going to go straight to what they're asking us to do first. So 1 over b minus a times the integral of a to b, f of x dx. And b minus a on this one will be 3 minus 0, or 3. So I'm going to have 1 over 3 times the integral of 0 to 3 of negative x squared over 2 dx. And you throw that into the calculator, you're going to get a value of negative 3 over 2. So one of the questions, not one of the questions, I'll probably go into this more detail in class, but one of the things we can look at with this one is going, I have a constant. I have a negative here, and one of the rules tells me I can pull the negative outside the integral. I even have a fraction here that I can pull outside the integral. So we could have rewritten this as negative 1 over 6, because 2 times 3 is 6, the integral of 0 to 3 of x squared dx. And yes, it would have given me the exact same answer of negative 3 over 2. If it doesn't give you the same answer, then you made a mistake. But now keep in mind, this is the average value. So between those 2 points, the average rate of change is. All right. So, and then it's showing this one here, that this being the curve of f of x, and this is the interval from a to b, then we're going to have some kind of instantaneous rate of change. And between these 2 points, it can, you'll have whatever value, and you're going to get an average rate of change. You can get the average rate of change by doing the integral and asking for the average. So anyways, you're taking the integral and then dividing it by your c value or your x values, just like you normally would. Because you'll come out and do, as you learn to do antiderivatives, what the work you're doing is you're subtracting your 2 y values. But when I ask you for the average, then you're dividing by the x values. So you're finding the average rate of change going backwards. So keep that one in mind, because if you understand that, when they ask you for the average rate, you'll know what to do. Okay, so now they're getting into, they want to give you your first little touch on antiderivatives, but they're asking you the derivative of an integral. So we have d dx of a of the integral a to x f of t dt is simply going to be f of x. And one of the things to identify is that your derivative and integrals are opposite operations, which means they cancel each other out. Just like the square root of x squared is just x. So, and one of the things that they'll show you when, and I might as well go ahead and give it to you, is what they'll do if I'm looking at just this part of the problem, is that you're going to find the antiderivative with respect to x minus the antiderivative of f with respect to a. That would be this guy. But if I took the derivative of this mess, this is a constant, because a is a constant value. That's a constant. So that goes away, and then you will be just left with f of x, which is the derivative of the other guy with respect to x. Now that may or may not make sense, but we'll talk about more in class. So they want you to start playing with antiderivatives using that rule. So on this one here, I have 0 to pi, a sine of x, dx. Now I'm going to show some notation, and yes, you have to use this notation. Okay, now here's what we need. We need the function whose derivative is sine of x. So this is where you guys go, well, derivative sine is cosine, derivative cosine is negative sine. Oh, hey, sine. But I don't have a negative here, so the cosine, guess what? The cosine is going to be negative. Because the derivative cosine is sine, negative sine, but I have this negative, and those two negatives cancel each other out. But I want to evaluate it from 0 to pi. 0 to pi. So you guys, we're almost there. We're almost at this point here. We want f of x minus f of a. That's okay. So I take, I'm going to leave the negative on the outside. So I do cosine of the x, so pi, cosine of pi minus cosine of 0. So I'm going to get negative, and cosine at pi is negative 1, minus cosine at 0, which is just 1. And negative 1 and negative 1 will give us negative 2. And negative 2 and negative 1 will give us a positive 2. So in the end, that's our answer. So the answer to this guy here is just 2. Okay, the notation that I'm expecting you to use is you take the derivative, draw this line down, and it's your upper and lower limits of integration. And you always start with your upper limit. Okay, so let's try another one. I want the integral of 1 to e of 1 over x dx. And 1 over x, the antiderivative for 1 over x is just the natural log of x. Natural log of x evaluated from 1 to e. So you get the natural log of e minus the natural log of 1. Well, the natural log of e to what power gives you e, is 1. And e to the first power, e to what power will give me 1? E to the 0 power. So your answer to this guy is just 1. Okay. Let's try another one. So I have negative 1 to 2 of 3x squared dx. So negative 1 to 2 of 3x squared dx. And this is when I get to remind you guys, this is the power rule. But keep in mind, we're doing antiderivative. So on the antiderivative power rule, you got to do opposite of what they're telling you. So you're going to take 3x squared, add 1, and then divide by your new exponent. Because remember, the power rule, we would bring the 2 down and then subtract 1. So in this case, we're going to add 1 and then divide by it, because originally we multiplied by the power. Now we're going to divide by the power. And so what we get here is 3x cubed over 3, and the 3's are going to cancel out. So what we get is x cubed, and we want to evaluate him at negative 1 to 2. So we get 2 cubed minus negative 1 cubed. So this is going to give us 8 minus a negative 1, or 8 plus 1, which gives us 9. So the answer to this guy is 9. Okay, these are all a lot of basic antiderivatives, and so it's going to take time to get used to playing with these. But one thing that they're asking you to do is basically look at, now they didn't give us x as our top integral, that's why we were doing, but they're identifying the top one minus the lower limit. Okay, again, it was about a 15-minute video, so at least these are 2 short ones. And there you guys go. So this is the end of section 5.3. We have one more to go after this one. So good luck.